For question 8 from the calorimetry checkpoint module, there's a lot of different questions we kind of have to answer just about the basics of calorimetry and kind of how calorimetry works. And it's not a perfect system. There is heat that is lost in reality. So in this case, calcium oxide reacts with water in a coffee cup calorimeter. The temperature of the solution increases by 24.1 degree Celsius. In this experiment, in this case, where the water is going to get hot. So that case, if the water is getting hot, it has the potential to lose heat to the surroundings. So I would say we have the potential for heat or the energy to transfer out of the calorimeter in that case, because the calorimeter is going to become higher in temperature than the surroundings. The temperature that would change that would occur in a perfectly insulated calorimeter is smaller. So because we're losing some of the energy to the surroundings, the energy change that we're going to observe, we're going to measure, is actually going to be smaller than it would be if it was a truly isolated system. And because we're measuring a smaller change in energy, a smaller change in temperature, we're going to find a smaller change in energy, and the actual enthalpy change will also be smaller as well based on that. They give us another reaction. Barium hydroxide reacts with ammonium or ammonium thiocyanate, and the temperature of this solution decreases. So this solution now is going to get colder than the surroundings, which means that if it's colder than the surroundings, here the error would be that heat could flow into the calorimeter, because now the calorimeter is cooler than the surroundings, right? And heat's always going to go from an area of high heat to an area of low heat. So because this reaction is getting colder, I would imagine that heat from the surroundings would flow into this calorimeter. And again, because we're going to have some of that energy lost, right? We're going to observe this temperature change. The temperature change would not be as great as it otherwise would be because some energy is leaking in from the surroundings. So I would say that again, we're going to see a smaller change in temperature because of that energy getting in from the outside. And because we see and observe a smaller change in temperature, we're going to calculate a smaller change in enthalpy as well, all because the calorimetry that we do in lab is truly not a closed system. It's truly not a perfect setup where, in this case, we are going to have some energy loss to the surroundings.